convolutional neural network? Already covered. Huh? Chapter 2. So you know the architecture of CNN already, right? CNN neural network. So no cover architecture. Oh, it's okay. So if you cover, then this one should be very simple for you. But if no, then I will cover the fundamentals of neural networks. Okay, so before we continue the chapter, so as usual, so recap on what we have covered in the past 2 weeks. So last week, so we have a midterm test, and then 2 weeks ago, we covered a chapter known as the unsupervised machine learning. Okay, so this is a chapter 8. So in the chapter 8, unsupervised, we have seen how the unsupervised machine learning works, the flow. Okay, so we have a data set. Okay, so we will perform some training process. Okay, and then we extract the features, which is only X. Alright, and then we use to train the model. That's it. So it's not like the supervised machine learning. With supervised machine learning, we have a data set, we extract features and label, we split the data 80%, 20%, 70%, 30%, right? And then we use for train the model. So in the unsupervised machine learning, it's more simple, right? There's no splitting data, and then you do not need to extract the Y. So we just need X in this case. So what is the purpose for unsupervised? We use for clustering or grouping. So in other words, those points that have the same properties, we put them into one cluster, one group. The point that is not having the same properties, we don't put them together. So we put them away. Okay. And then we have to cover some of the algorithms. Okay. K-means. We have a mean shift. And then we have this Gaussian mixture models. And the last algorithm we cover is the hierarchical clustering. So under hierarchical clustering, we have two algorithms, which is the bottom up and also the top down. Okay, but top down is not our scope, so we just cover the bottom up 2 weeks ago. And then lastly, we have covered how to measure the performance. Right, how to measure the performance. So we have two methods. One is the intra-cluster cohesions and also inter-cluster separations. Okay, so if your intra-cluster cohesion is very close, meaning that your models have successfully put the point that have the same property into one group. Okay, so if as long as your intra-cluster cohesion, the value is very low, then it means that you have done a good job. And then the inter-cluster separation is measuring like how far two clusters is. If very far, then it means that your models have successfully put these 2 points that have a different properties away. And then this parameter you should have obtained a high value as possible. This one as low possible. Okay. So these are the things that we covered 2 weeks ago. The flow, what is the purpose, and then we cover 4 algorithms, and then last one is how to measure the performance. That's it. Okay. So now let's move on this chapter 9, which is known as artificial neural networks. So what we are going to cover in this chapters within these 2 hours. So we will cover a little bit of neuroscience, which is called biological neural networks, also known as BNN. Yeah, sometimes it's known as a brain. Right, so we will cover a little bit on the neuroscience, right? What is the components inside BNN and what is the functions of each of the components and how they are connected to each other, and so on and so forth. And then later on we have perceptron. So perceptron is one of the fundamental type of neural networks. Okay, so we won't go into details on the multi-layer. We will just cover on the perceptron, which is a single layer. Then we will see how it works, how it be used to predict some things, and how the training process for a perceptron. Okay, so if you can understand the perceptron, then shouldn't be a problem for you to understand multi-layer neural networks, convolutional neural networks, or recurrent neural network, or fast RCN, and so on and so forth. Okay, so all the neural networks are actually based on this perceptron. So we're going to see the in terms of the mathematical modeling, right? How it's going to calculate from input until the output. Okay, and then lastly, we will cover a little bit of the architecture of multi-layer neural network. How are we going to draw the multi-layer neural network? How this perceptron is connected to each other to form the multi-layer neural networks. Okay, so let's begin. So what is artificial neural network? It is known as neural net sometimes, ANN sometimes. So what is the purpose for artificial neural networks? Most of the time, it's been used for just like the supervised machine learning. We use for classifications, predictions. Okay, sometimes we use for unsupervised, but it's not very common, right? So the main purpose of neural network is still prediction, just like supervised machine learning. Okay. So before we dive into BNN and also the ANN, so let's look at the big pictures. What is the difference between all of them, right? The big pictures of what is artificial intelligence, machine learning, neural networks, and deep learning. So you probably have seen that deep learning, neural networks. What is the relationship between them? And what is the difference between machine learning and also the artificial neural networks? So look at these pictures. What is artificial intelligence? It's applications that having human behaviors, right? For example, chatbots, Waze, Siri, all the applications that able to perform like a humans. Okay, that is the artificial intelligence. So to build artificial intelligence, there are many methods. You can use rule-based, like you just take if-else statement to instruct the machine application to perform the task. Another way is you use the machine learning that we covered the 2 weeks supervised and unsupervised. We use some equations, mathematical modeling to teach the machine, right, how to predict something, how to perform the clustering. Okay, then further down we have the neural networks. Okay, so neural network is also a type of the machine learning. Okay, a type of the machine learning that where we do not provide the if-else rules, but instead the neural network will learn the information from themselves. So, but what's the main point? What is the difference? The difference between machine learning and neural network here. Okay, so if you recall back the flow, the process flow of the machine learning. So what is the machine? Let's say we talk about the supervised machine learning. Okay, we use supervised machine learning as our case here. What is the process flow? We need to prepare data sets. Okay, so from the data set, we need to extract the features. So you have, let's say, x1, x2, x3, x4. Right, you extract these 4 features for a training purpose later on. Okay, then you perform the training. Let's say you split the data. Okay, and then you train the models. So you have these 4x, x1, x2, x3, x4. Okay, so in this, when we zoom in into these areas, right, extract the features, so we have to manually select, right, perform some tests. For example, T-square test, we have to perform correlation tests, and to find out which features are significant and which features is not really significant. If not significant, we have to manually drop out. Important when predicting. Okay, so this one, it depends on your knowledge as well. So if you have a lack of the knowledge of how to select the good features, then at the end you may build a wrong models. I'll give you one example. If you want to build a model that used to predict agendas, let's say yes or no, also female or male. So you want to predict agendas, and you have 4 features here. Okay, so let's say x1, 2, 3, and 4. And then from your data set, you have these features: weight, you have height, you have this maybe whether a person having long hair or not. And then the last features, you have a student ID. Okay, you have these 4 features, and then in supervised machine learning, you have to manually perform some tasks to identify which features is important. If let's say you don't know which one to select, you throw all the x1, 2, 3, 4 into the supervised machine learning for training purpose. What happens next here is this supervised machine learning will treat this x1, 2, 3, and 4 equally important. It will treat this x1, 2, 3, 4 equally important during training process. But do you think that the student ID is important features to predict a gender? No. But if you put this student ID, what happens? You are creating some noise to the machine learning. The machine learning will just learn. And then we just assume that, oh, student ID is one of the important features to predict a gender. Okay, so now, what happened to the neural networks? In the neural network, the different things is that you have a data set. Let's say you have the same features, x1, x2, x3, and x4. Okay, so you can actually just throw all these features, okay, into the model. Okay, in the supervised machine learning, you need to manually select which one is important. But in neural network, it's not necessary to do that, because what happens, if you throw this x1, 2, 3, 4 into your models, this model has some ability to perform some fine-tuning. So during the fine-tuning, this artificial neural network will identify which features is important. Okay, I'm going to show you later on in more details how the artificial neural network is so smart to identify which features is important and which features is not important. Yeah. If the features that are important, eventually during the fine-tuning, we will have a high value to x1. Let's say the weight. Okay, if x1 is important, eventually you will get a high weight value. x2, let's say height is also important, you will get a high value. This is also very important, you will get a high value. Let's say I call it as a W2, W3, and x4 is student ID, not very important. During the fine-tuning process, the artificial neural network will know that x4 is not bringing significant value or not significant role here. Eventually, you will get a very low weight here. That is the difference between neural network and also machine learning. In the machine learning, it will treat all the features equally important. But in the neural network, during the fine-tuning, we call it as a backpropagation process. It will assign the weight to each of these features. The feature that important, very important role, they will gain a high weight value. Those poor or not really important features, they will gain a very low weight value. That is the powerful things about artificial neural networks. So I'm going to show you later on how the backpropagation works, the overall process, how we train the models, and how we adjust the weight for every single features. Okay, and then next, we have the deep learning. So what is deep learning here is basically built from the neural network. Okay, so we have a neural network, it's not enough. If we replicate this neural network into multiple layers, then it will be known as the deep learnings. Okay, so I will not go into details of what is deep learnings. I will just cover the fundamentals of the building blocks, the most fundamental elements that used to build the deep learnings, which is known as the neurons. Okay, so now you know what is the relationship between each of them. Alright, so before we move on to the artificial neural networks, so let's cover a little bit what is biological neural networks. Is known as the BNN. Okay, so in our brain, it's actually formed by millions of billion of the neurons. Okay, so what is neurons? Neuron is just like a processor. Okay, just like you have a CPU, you have a processor. What is the processor? Used to process the information. Correct enough. Okay, so the more neuron you have, then the more processing. You have a processor, and then more information that you're inside your brain, and then process here and there. Okay, so let's cover a little bit of the history of what is a neuron here. So on the bottom left corner here, so that is the first version of the neuron that is actually run by the the Spanish, very famous Spanish neuroscientist, is known as the Santiago Romans, right, in the 1899. So again, he dyed the neurons using the actual brain cells. So he died, and then you go and observe under the microscope. Okay, and then this is how he draw. Then from due to the from time being, you will see that we have a better version of a neuron. So this is how a neuron looks like. So always remember, what is neuron is actually a smallest element that inside your brain you used to process the information. Okay, so a neuron itself serves no purpose. Pretty useless if we have one neuron here. But when you connect to you connect a neuron to each other, then you become a very powerful or very very strong mechanism, right? So, and then human try to recreate this mechanism into the computing. So they want to build something that a machine can learn just like the humans. Okay, then they try to understand the principle behind the biological neural networks, and then they replicate into the artificial intelligence, artificial neural networks. Okay, so now let's zoom in into what is the neurons, the components of the neurons here. So neuron consists of four main components. Okay, so which is known as soma, dendrites, axon, and synapse. So assume that you see something, alright, you see something, you touch some things. So the moment that you see something, you touch some things, that's actually known as the input. That you see something, you touch something, it's all known as the inputs. But in biological neural network, it is known as dendrites. Okay, so the information will actually start from here. So all this information input here, you see something, you touch something, whatever features, it will send through a soma or the nucleus. Okay, so this is the soma, this is the nucleus. So this input will pass through into the soma, process it. Just like your PC processor. So after you process these informations, what do you get? You got the input, you eat something, you generate something. Okay, you get some output. So the output that generate here, we will propagate, transmit through axon. The long tail here is actually known as an axon. You have an input, go to the processor, generate some output, axons. Okay, so the output that generated from one neuron here, this is actually one neuron, may not sufficient to give you decisions. Then you have to further pass this information to another neuron to further process this information. Just like, let's say you give you pictures. You look at the pictures, so you get some pictures, maybe you process, the first neuron process, it is an animal, right? It is an animal. So then this information animal will pass into another neuron, further process, get more pictures, or then you further analyze or generate some decision, or this is elephant. Okay, maybe the elephant you further process, go to pass all the information, more information into another neuron, then you identify the species. Just like you are passing one information from one neuron to another. So the moment that you pass this information to another neuron here, then we will just repeat the same process. So you have more features, so you're going to pass this information to here, then we'll further process. So this is nucleus, so you have axons, then we'll repeat. So then we'll see that you will see that in actuals there are hundreds, billions interconnected sets of the neurons. Alright, so now let's zoom in a little bit on this part, which is the transmission here. So when we pass this information from one neuron to another neuron, what happens? So if you have this one information, assume that this is the axon, you have some information pass to here. So this information will pass to another neuron. Okay, which is the dendrites here. There's no physical touch here, right? Those not physical connected, but there is some gap here. But in order to pass this information from one neuron to another neuron, there's one reaction called synapse. Okay, that will happen in between. So what is synapse? So the moment that it passes the information, it will create some sparkling. create some sparkling in between, lightning. Okay. So like the electrical pulse lah. Alright. So there's a so-called electrical potential here. And then it will create some bright, right? Some sparkling here. So then we repeat. So the moment that you pass here, then you will see another spark. Okay, so you scan your brain using some MRI. Then this is how your brain look like. The more that you think, this is how it look like. If your brain is like somehow dark, then it means that you're not. and something wrong with the brain. You're not thinking. You're not reasoning. Okay, maybe during the sleeping time, yeah, the brain is not working, and then there's no sparkling, there's no lightning at all. Okay, so that is how the brains look like. Summary: what is biological neural networks? We have four components. Dendrite receive the information, go to the soma, which is the nucleus, the processor unit, process this information, generate the output called axons. So in order to pass this information from one neuron to another neuron, synapse happens. So synapse will create some electrical impulse here, and then create some lightning. Then we repeat this same process. 4 components. So why we need these 4 components? Because the scientists found that a brain is a very strong mechanism to learn something and make decisions. So they try to recreate something similar into the computing area. Okay, so is that clear? 4 components. So now let's move away a bit from the neuroscience. Okay, now we move on into the artificial neural networks. So what is artificial neural networks? Consists of numbers of very simple processors known as neurons, which are analogous to the B and N in the brain. Okay, so there are 4 components as well in the artificial neural networks, which is the input. So you can just assume that this is biological neural network. It's called BNN. Okay, so in artificial neural networks, we have the dendrite as well, but it is known as input to receive the data. Okay, and then we have a processor unit. It's known as the neuron to process the information. The moment that you process the information, it will actually generate the output. Okay, this output can transmit the data to another neuron. In order to transmit the data to another neuron, it will pass through the synapse. But in artificial neural network, it is known as the weight. Same 4 components: input, processor, which is called neuron, output, and then last one is called weight. Okay, but in biological neural network, it's known as synapse. In ANN, it's known as the weight. So the weight here play very important roles, most crucial roles in the overall architecture neural networks. So during the whole training process, whatever prediction is depend on this value, weight. Okay. So now I'm going to explain to you how the neural network works using perceptron. So what is perceptron? It is known as single neuron models or single layer perceptron. It is a well-known type of neural networks. It's a fundamental of neural network that you must understand first before you go into details or you go others more complicated neural network models. For example, convolutional neural network, multi-layer neural networks. Okay. So before understand those, you have to understand how perceptron works first. Okay. So this is the architecture for an perceptron generated by these guys. Okay, it's a scientist, Frank Rosenberg in 1985, and this is the models. All right, so I'm going to explain to you every single element. Right, what is the purpose of an input? What is the weight? What is the summation? What is the step function? And what is the output? Before we go into the predictions and also training process. Okay. Okay, so firstly, we have input layer. Okay, we have input layer. So in this case, let's say we have x1, x2, and x3. So what is input layer here is referred to the feature. Okay, so always remember when you are building your neural networks, this x1, 2, 3 must be in numerical value. Okay. Alright. So just like the previous case, we have x1, 2, 3, and 4. We had a weight, height. It's all in numerical value. But if you have some categorical data, let's say, do you have a long hair? Yes or no? So you have to convert this into some value first, right? You do some pre-processing. You go and encode it into 1 and 0. Then you have some value here, 1 and 0. You have some value here. After you have some value, you convert this to the value. Then you perform some normalization or standardization onto your input first. Okay. So now this is the input layer. So what happened next here is, in the perceptron, now we are talking about the perceptron. So you have to assume that this is actually like the another neuron. That you have to assume that you have another neuron here, that it will generate some output. So this output has to pass into another neuron. In order to pass into another neuron, you have some synapse here, but in artificial neural network, it is known as weight. So every single input here, we are going to give a weight. Okay, so every single neuron, you have to assign a weight to this input. At the first iteration, this weight here will be randomly generated. At the first iterations. Okay? So we have W1 corresponding to the X1, W2 to the X2, W3 and the X3. Okay, so this is the synapse or the weight. And next we have these summations, okay, just like the processor units. Okay, so we have these summations together with the activation functions. Okay, sometimes it comes with a threshold value. Okay, so you have to assume that this part is a processor unit, just like a neuron. Okay, just like a neuron. What is the purpose for processor? Process the information. Okay, so the moment that you process the information, what happened here? There's some calculation take place. So I'm going to show you how it works later, so how the calculation take place. So you have an input layers, you have some features here. We're going to assign the weight, which is the synapse in the biological neural networks, to each of the input. And then all this information will go into this processor units. Okay, so go to this processor unit to generate some predicted output. Okay, or predicted output, or predicted Y. That's it. So that is the architecture for a perceptron. We have 4 units, input layer, we have the weight just like a synapse, we have a processor, and then finally generate some predicted output. Okay, is that clear? So we have 4 components, just like biological neural networks. Now, let's move on a little bit further. How are we going to use this perceptron to predict some output? Okay, so assume that you want to predict. You have the 3 input here. So x1, let's say, is the weight. So x2 is, let's say, is the height. I said x3 is equal to whether a person having a long hair or not. Okay, yes or no. Okay, and one thing that I want to highlight here is your predicted output. If your predicted output is binary classifications, right, you just want to predict yes or no, then you have only 1 neuron. In the perceptron, the purpose of the perceptron is used to perform binary classification. Yes or no, true or false, female or male. If you have a binary classification, you have 1 neuron. But for other neural network type, if you want to perform multi-class, okay, you want to predict, let's say, 3 classes. Yeah, cat, dog, and let's say elephant. Then in your upper layer, you should have 3 neurons here. So this one is used to predict the cat, this one is to predict the dog, and this one is to predict the elephant. So it depends also what you want to perform, what you want to predict. Output multi-class, it depends on how many classes that you have. If you want to predict binary classification, then you have only one neuron. If you want to predict some continuous value, then you have also only one neuron. Okay, so now come back to here. So you have this as 1, 2, 3 here. Then you want to predict a genders. Let's say we define 1 is female, and then 0 is male. So we have to predefine first. Always remember, machine cannot process string. They can only process numerical value. So whenever we have this string, you have to convert into some value first, so that it can process. It can perform some calculations here. Okay, so what happened here is, so let's say now you have some value. Let's say weight, it's a 180. No, wait now. Let's say 70. Height you have 180. And then whether you have a long hair or not, you have some yes, right? Yes or no. So you have some value here. And then assume that this model is already stable, right? So we assume this model is already stable. It already optimized. Okay, so we are going to see that how the neural network is used to predict some output. Assume that the weight 1, 2, 3 is already optimized. What happened here is this processor will perform some calculations, multiply this x1 with w1. It will multiply this x1, w1. This w1 is some value, let's say 0.3. Okay, and then plus this 180 multiply x w2 and multiply x3 with w3, and then we just add up together. That's called as summations. Okay, this process multiplication, the dot product with the x1 w1 plus x2 w2 plus x3 w3, it is known as summations. We just multiply and add up together. Okay, so once you add up together, you will get some value here. After you go through this, it will generate some weighted sum. Okay, we just simply multiply the weight with the input value and add up together. Okay, the moment you add up together, you will get some value. It is known as the weighted sum. That at this point, okay, you multiply, add with this multiplication, add with this, then you will get some value. It's known as weighted sum. And this weighted sum serves no purpose. Okay, this weighted sum serves no purpose. You have to remember, you have a value here, multiply, value, multiply, value, multiply. Maybe you will get some value, let's say 0.5. What is the meaning with this 0.5? There's no purpose. So that's why we need these activation functions to help this 0.5 generate some output, whether is it female or male. Okay, I'll repeat again. You have input weight, multiply, 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 add up together. Go to this process. You get some value, which is, let's say, 0.5. I will call it as weighted sum. And this weighted sum have to go into another process known as activation functions. In the perceptron, we use step functions. Okay, so a little bit on the activation function. So there are several types of activation functions here. For example, step functions, psi functions, sigmoid functions, and linear functions. Every single function serves different purpose. If you want to perform binary classifications, you can use step functions, psi function, or sigmoid functions. If you want to predict some continuous value, you have to use linear functions. If I want to use, let's say you use a convolutional neural network, most of the time we use value functions for the hidden layers. Upper layer, we have to use a softmax functions. Okay, softmax is to generate some probability. Okay, so that one is for convolutional, but in this perceptron, we are going to use only step functions. So how step function works is pretty simple. Look at this graph, okay? So it means that any value that you generated from this summation, if this value is more than zero, then we classify into +1. Anything that's below 0, then we classify as 0. That's it. Kind of a rule base. I'll repeat again. Okay, I'll repeat again. So you have some value here. It's known as the weighted sum. This value serves no purpose. So this value had to go into this activation functions. So the activation function for the perceptron, it is known as step functions. So how step function works? Look at this equation properly. If this x here, the x here is referred to the weighted sum. I will call it as this, it's the weighted sum. If this value more or equal to 0, then we assign to positive 1. If less than 0, assign to 0. So now 0.5, check with the activation function. Is it more than 0? Yes. Then we have value 1. So what is 1? 1 is female. That's it. This is how artificial neural network works. We just simply summarize. So we just simply product multiply this x1 w1 plus x2 w2 plus x3 w3, get some value. So this value go into the activation function. That the activation function to help you to generate some output value. For example, in this case. Okay. So if you use sign function, anything more than 0, assign to positive 1. Anything less than 0, assign to negative 1. So what is positive 1, negative 1 here is some predefined class. So always remember, machines can only process numerical value. So we cannot process female, male, yes or no. We have to convert into some numerical value. Okay, so should be a problem to solve here. This is how artificial neural network works, used for prediction. And I assume that this W1, 2, 3 is already stable. It's already stable. Okay, so now let's move on. So that's the when we combine all is what I say just now. We go x1 to x1, so you will get some weighted value here. And then this weighted value, weighted sum here, will go through this activation function. It is known as the step functions. What is the threshold value here? Sometimes this threshold, this activation function will come with a threshold value. So what is this threshold value? It is known as the bias. Sometimes the threshold value, threshold is equal to bias. So what is the bias? It's actually a value that helps you to adjust your predicted y that's close to the actual y. Sometimes you should have, your actual output, let's say your actual output is like something like this. This is your actual. So the predicted value that you obtain something like this. So you have some offset here. So we want to close this offset. So we assign a bias. Okay, so we want to reduce the offset between the actual and so predict. So we assign some offset. So we assign some threshold. We close up the gaps. Okay, don't worry about how to obtain the threshold value. The machine will assign for you. Okay, and then you will adjust accordingly, adjust to optimize this value. Okay, sometimes you will get the bias 0, sometimes you get some very minimal value. Okay, so that is the process how a neural network works. Now, shall we continue? You want to take a breath first? 5 minutes? Okay, 5 minutes, then we go into another topic is how we train these models. Now is has seen the overall process, right? So assume that the neural network is already stable, and we have seen how to use some input and fit into these summations, and then from this summation we have some weighted sum. From the weighted sum, go to the activation function to give you predicted output. Okay, so your questions might be, all right. So the question is that how to get this W, how to optimize this value W1, W2, and W3. So this W1, W2, and W3 is very crucial because you may see that in the overall structure here, this input is a constant, right? You can't change the data set. So in your overall structures here, your accuracy of your models is solely depends on this weight. If you get this weight is not optimized, then the whole models will wrong. You can't really predict your the input values. So we have to find the weight, optimize the weight, and get the stable weight for the predictions. So the question is how to obtain this stable W1, W2, and W3. So now we are going to cover how to optimize this W1, W2, and W3. Okay, so in the next slide here, okay, so perceptron training algorithms. Okay, so now let's see step by step how this perceptron is being built. So now assume that I want to build a model that to predict genders. So we have x1 and x2. Okay, so let's say we have x1 and x2. x1 maybe long hair. So maybe x2 you do have a 6 mouth. Let's say you have 1, yes, 0, no. So long hair, yes. Then you have no. Let's say you have 2 features. You just want to build your model solely based on these 2 features. Short hair. 6 mouth? Do you have small? Okay, 6 mouth. Okay. So let's say you have a 2 features you want to build. What is the y here? So you want to predict whether it is a female or male. Right. So let's say female is 1, male is 0. Okay, done. So we prepared all the data set, everything's done. So now we start to build your neural network. So you have the input layer. So input layer, how many neurons? Depends on how many features. You have x1 and x2. So we have x1 and x2. So when you have this x1 and x2, you will have 2 weights here, W1 and W2. Okay, so this W1 and W2 will go through this processor. The first process is known as the summation. Okay, just like just now. We have some value for x1, let's say in this case 1. And then we have maybe 0. Let's say you have some data set here 1, 1, 1, 0, 0, 1, and so on. So we take this one. Okay, 1, 1, 1, 1. Multiply the W1. So during the training process, if you look at the first one, in step 1, initialization, we set initial weight to some random number. So assume that this W1 I assign like 0.3. This W2 assigned to 0.4. Okay, so it's not our control. Let the machine to decide. Okay, so we randomly assign this 0.3, 0.4, so that later on the machine will keep fine-tuning this value, optimize this value. So let's say you have some value here, let's say 1 here. Okay, you multiply. So you will get some value. So what is the value here? That generated from the summation? Weighted sum. Yeah, weighted sum. The value generated from this summation is called weighted sum. So that is the summation process. So this process will give you some value. So let's say 1 multiply this plus 1 multiply this, you get what? Okay, 1 plus 1 multiply 0.3 plus 1 multiply 0.4, you get 0.7. So you will get some 0.7, let's say in this case. So this 0.7 serves no purpose. Okay, no purpose. So what you're going to do here is you have to go into this activation function. In the perceptron, we use step function. Let's say you have some bias or the threshold value. Assume that the threshold value is 0.5. Let's say the machine will set for you. So there's some bias here. Okay. So what we'll do here is look at this equation. So what the step function is, if your weighted sum is more than the threshold value, then we assign to 1. If the x is less than the threshold value, assign to 0. So now we have this weighted sum. We have these step functions. So now we will check, substitute this x into 0.7. Okay, what is the threshold value? Let's say 0.5. 0.7 is it more than 0.5 or 0.7 is it less than 0.5? Hmm? More or less? More, right? Yeah? More. 0.7 more than 0.5. So we are going to fire these rules. Fire. So our output is 1. So what does it mean by this 1? This 1 here is your predicted Y, predicted output. I repeat again, you have an input which is your data set. So initializations of the weight, so this W1, W2 and the threshold, we let the computer to decide. Randomly assigned for the first iterations. You multiply this with this, multiply this with this, you will get some weighted sum, which is 0.7, no purpose. Right? No, so we have to get some so-called useful information from the 0.7. So we have to go through this activation function. In this step, in the perceptron, we're going to use the step function here. So that is the formula for the step function. So we're going to compare. If this value weighted sum here, is it more than this threshold value? If yes, assign to 1. If less than 0.5, assign to 0. Obviously, this is more than 0.5, so we assign 1. Okay, what happened next? In the training process, later on, this predicted Y is going to compare with the actual Y. Right? From your data set, you should have x1, x2, and y. Let's say you have some 0, 0, and some have some value. So yeah, the predicted value here will later on compare with the actual Y. So why you need to compare? You want to obtain the error. Sometimes it is known as the loss functions that you will see some advanced neural network, that convolutional neural networks that we call it as a loss function. But I will call it as an error as well. Same things. So you get some errors here. So you can just simply compare. Okay, how to compare? You just simply use the predicted Y, actual Y minus with the predicted Y in the perceptron. Okay, you just simply minus. Okay, so you get some loss functions. So what's the purpose for the loss functions? We need these errors to feedback to here. So this feedback process is known as back propagations. Okay, this process from the left to right, right? You want to predict something is called as feed forward. Okay, so you obtain some value, you compare, you get an error. So this error will go through back propagation process. So what is the purpose for back propagation process? It is used to fine tune this value. Okay, it used to fine tune this value. So how to fine tune this value? You have to use this equations, which is W. Let's say I'm talking about the 1. Okay, W1 new is equal to W1, the OW, which is 0.3, plus the collections. So what is the collections? Which is equal to the alpha learning rate. It is known as learning rate. By default, we use 0.1. By default value use 0.1. It's how fast, how quick that you want the machine to learn. Okay? So normally we set 0.1 by default, multiply with the input value, multiply with the error. That's it. In the perceptron, we use this method. But for convolutional and for other neural network, we're going to use this gradient descent to optimize it. Okay, but for the perceptron, we simply get the loss function and substitute this equation. Okay, I'm going to show you step by step how we calculate it later. I repeat what happens during the training process. First iteration, we have input randomly assigned W1, W2, multiply this value, sum up together, get some weighted sum. So this weighted sum here compared to the threshold value. If more than, assign to 1, less than, assign to 0. More than, assign to 1. So the 1 value here is predicted Y. So this predicted Y compare with the actual value. we get some errors. So this error feedback to here, so that we can substitute into this equation to obtain the new weight. So we're going to update this weight. Let's say 0.1. Let's say update 0.2. Repeat until this value becomes stable. That's it. So this is the full process of how we train a neural networks. Okay, so you will see that the general ideas of neural network, any neural network models, is just to fine-tune the weight, as well as the bias. But sometimes the bias is fixed, but sometimes you adjust this bias as well. Okay, so always remember this value is fixed. The activation function that we use also fixed. So what changed is the weight and the bias. That's it. So that is how we train the models. So now recall back in the beginning of the sections. What is the difference between neural network and machine learning? Machine learning, all the inputs, we will treat them equally important. But in this case, you will see that this weight will adjust. Sometimes it becomes 0.3, it's important. But in the next iteration, it dropped to 0.1. It means that the machine will assume that this input is not significant. It's why the value decreased. Then you will see that this W2 initially 0.4 also decreased. It means that this feature is also not really significant. It dropped. So this weight here is so how significant this input play the role inside this architecture. If this feature is important, you will get high value. If not important, you will get low value. And this value will keep adjusting. Okay, and it is not same. This W1 is not same as the W2. Sometimes it's same, sometimes it's not same. So the machine will fine tune it, adjust the value, and optimize the value. Okay, so now what happens? We go to the calculations. Okay, let's look at one of the examples here. Alright, so you have this 4 data set 0, 0, 0, 1, 1, 0, 1, 1. So what is this? You assume that this is 2 features. One is the long hair, whether you have a 6 mouth. Yeah, I'm going to modify a little bit. So assume that this is 0, 0. So you have 0, 1, 1, 0, and 1, 1. Right? And then you have the actual output. The desired output is known as the actual output 0, 0, 0, 1. That's it. So that is your data set. So what is going on here is we're going to take the first data set first. Okay, the remaining we don't see. Okay, we take the first data set, put inside here, so we have 0, 0. Okay, so what happens here is the machine will randomly assign the weight. Let's say the initial weight is 0.3. And the second weight here is negative 0.1. Okay, so we're going to perform what? We perform the calculations. 0 multiply 0.3 plus 0 plus this. Okay, so you just 0 multiply this, 0 multiply this, you will get 0. Okay, so now what is the threshold value? The threshold value here is 0.2. Okay, the threshold value here is 0.2. So now, is the 0 less than 0.2 or 0 more than 0.2? Less than 0.2. Anyone say 0 is more than 0.2? Yeah. No? 0 less than 0.2. Yeah, yesterday some students say 0 more than 0.2. Very confident though. 0 less than 0.2. If 0 less than 0.2, the predicted output is 0. Okay? So you get predicted output is 0. We just simply multiply, compare with the threshold value, then we get predicted value here. So this predicted value, you have to compare with the actual y. So what is the actual y here? Is given in the data set is 0. So let's say the actual is also y. So how to get the error? You just simply minus this actual minus with the predict. Actual minus with the predict, 0 minus 0 you will get 0. Okay, so that is your loss functions, the error. So these errors, what happens? So we're going to send this value 0 here. back to here and adjust this. So how to adjust this depends on this equation. So I'm going to show you how to adjust this. Okay, so what is the OW? 0.3. What is the alpha? Learning rate is a constant given 0.1. In the practicals, when you build it, normally we set 0.1 as well. So this is 0.1. So what is the input? 0. What is the error? 0. So 0.3 plus 0.1 multiply 0, you will get 0.3. So it means that now 0.3 adjust, make it 0.3 as well. Repeat for the x2. Okay, so negative 0.1 plus 0.1 multiply 0. So you will get 0.1. So this one modify to negative 0.1. So in this iteration, you will see that the x1, w1 and w2 remain the same. At this iteration, it remains the same. So what happened here is we are going to repeat for the second data set. Just now we have done this. Now we repeat the second data set, which is 0 and 1. Now we're going to modify this 0 and 1. Repeat the same process, feedback, repeat, feedback, repeat. Okay, so you have to repeat until when? So you have to repeat until you've done all the data set. It is known as the first epoch, first round of trainings. When you have done all your data set and you monitor the weight value, so you will see that 0.3 drop to 0.2. So it's not stable. It's not stable means not convergence. So we have to continue to train the model. Repeat for the second round of training. Recycle this data set 0.011. You will monitor that it's also dropped to 0.3. It's not consistent yet. Repeat for third round of training. 0.2 drop to 0.1 and then increase back to 0.2. At W2 as well, it increased to 0.1. It's not stable yet. Repeat. So this is not stable also, right? And then last, you will see that all 0.1 consistent is all 0.1 consistent. And it is called as stable convergence. And you will notice that initial the value is 0.3. So after 5 rounds of training, it dropped to 0.1. This one negative 0.1, you train, it increased to 0.1. In other words, initially these features is very important, but after a few rounds of training, the machine assumes that these features is not important as it thinks. And then this one is negative 0.1, it's not very important, but it slowly increases to 0.1. It's pretty important in this architecture. So that's the meanings of the neural networks. Okay, so you'll see that overall in the architecture neural network, which one is the most important? The W1 and W2. Okay, it's very, very important role, the crucial roles to decide whether your model is accurate or not accurate. Okay, is that clear? Yeah. So yeah, that is the overall for architecture neural network. You will see that for multi-layer neural network or the converged neural network is about the same. We just replicate the neuron into multiple layers here. The more processor you need, it's all the same. So we process, calculate, get the errors, feedback, it's called backpropagation, fine-tuning the weight and all the bias. Okay, so you'll see that in your practicals, the moment that you train the models, that in this case actually a three neurons here. This one should be 3. So this is actually a neuron. Yeah, 3 neurons here. So if you have a 3 neurons, then you can observe the. Right, I changed yesterday. Yeah. So you have the weight here and also the bias. So this weight and the bias, the model will keep training and then keep updating the weight and also the bias. But don't worry, we don't really care about what is the value of the weight and the bias at the end of the day. We just let the machine to optimize these 2 values. Okay, this is not our job to check this value, right? So I just want to show you that we can obtain this value, we can monitor this. Okay, yeah. So another 5 minutes, yeah, then I will end this section. So we have a different type of neural networks. Yeah, single layer. So we have seen this is the single layers. It's known as a perceptron. Then we have multi-layer. So what is multi-layer? We just replicate this into more layers. That is called multi-layers. Okay, so multi-layer perceptron is a feed-forward neural network with more than one hidden layer. So always remember, whenever you see this multi-layer, it means that you have at least one hidden layer in between this input and output. So there's no hidden layer. So you have one input, you have one output, you straight away perform the calculations. What is multi-layer? It means that in between you have to add one more neuron, add one more processor in between. Okay. So that's the architectures of multi-layers, how the multi-layer look like. So assume that you have an input layers here. Okay, you have some output layers here. So we have some hidden layers, right? So it means that when you have these input layers, okay, so just like this, so you have this input layer. Okay, you have this output layer. So let's say now you have a binary classifications. So let's say you have a hidden layers here. It's called the hidden layer HL. So it means that this value input will go to here. We have W, we have W2, we have W3, we have W, we have W, and we have W. And then at the same time we have bias. We have bias, we have bias. And then you get some output. You will go through another W. Another W, another W. Then you have another bias. Okay, so this is not as multi-layer neural network. You have at least one hidden layer. The moment that you have at least one hidden layer, then you have to go through two calculations. Okay, so this is only single layer, no hidden layer. It means that you just perform one calculation. There's no hidden layers here. But here, this is multi-layer. You have at least one hidden layer. When you have one W, calculate, generate the output, calculate, generate the output. Two process. Okay. Okay, so sometimes you have these multi-layers. You have at least two layers here, but there will be more calculations. More calculation will take place. More memory will you need. Okay. So if you ask me how many layers should we design to build a neural network, there's no fixed answer. Right? The more, the better, but it consumes a lot of memory and time. Okay. Some neural network is fixed, like for example the VGG16. Okay, it has at least 16 to 19 layers. Okay, so means that sometimes you train the neural network, it takes few hours, few days, because you will see that a lot of calculation take place here. Okay, so always remember what is feed-forward. Feed-forward is where we want to predict some output using the neural networks. Right, we just go to one direction, from left to right. Okay, so what is back propagations? Back propagation is we feed back. Okay, we go to the left-hand side to right-hand side, get some predicted output, loss function, which is the error, send it back to here, so that we adjust the bit. Repeat again until it becomes stable. Alright. Okay, so to get this file, you can just go to the Google, and then you just type this back propagation, GIF, then you'll get a lot of this kind of images. Okay, so that's all for today. So let's do a little bit on the partial question. Not yet finished. Just few minutes. Do partial questions. And yeah, a team of researchers aim to predict a diabetes in Malaysia using multi-layer. So you will see this multi-layer means that you have at least one hidden layers. At least one hidden layers. You have to draw architecture, meaning you have to draw something out. So table 2 shows the data sets, design and architecture. Okay, so and label the structure clearly. Okay, so now I'm going to show you how to draw the multi-layer based on the data set given. Okay, so first thing first, what is the output? You want to predict a diabetes. And then you have to check the diabetes, is it a binary or is it multi-class? Is binary? Yes, then you can put one neuron here. Okay, so this is output layer. You have to label it. So case, type this. Yes or no? Okay, so input layer, how many neurons to draw them? It depends on how many features. You have patient ID, blood pressure, glucose, insulin, BMI, and age. 6. Then you have to draw 6. Okay, so it's called input layer. But here, actually, you will see that patient ID is not very important, right? So, by anyhow, you can just put inside the neural network. The neural network eventually will just abandon for you. It will adjust the weight, and then you will assign the low weight to the patient ID. As I mentioned, the overall ideas for the neural network is to assign the weight. Okay, so then you have to label it properly. So let's say this is patient ID, so you have to write. And we have the blood pressure, and so on and so forth. You have to label it yourself. So this is X1, X2, X3, X4, X5, and X6. Okay, and then this is multi-layer, so you should have at least one hidden layer. You can have hidden layer 2, hidden layer 3, hidden layer 4. It depends on how free are you during the exam. You are very free a lot of time, then you draw more layers. Okay, and then how many neurons? It depends on you also. You can draw 2, you can draw 3. Let's say in this case I draw 3 let's say. Also at the end you just join them. Okay, that's it. And how many marks? 4 marks. Is it bonus? Yes. Okay, so always remember, put the labels properly. What is the input layer, hidden layers, output layers. And then input layer, you have to label the features. You have to draw the neurons. You can put at least 2 layers, at least 1 hidden layers. You know, some students, based on my experience, you know how students draw. Students draw like this. Patient ID. Okay, and then blood pressure. Okay, and then glucose. Okay, and then diabetes. So based on my experience, a lot of students draw like this. So this is long. Yeah, we're not going to fit this input layer by layer, but we're going to put this input in parallel and all send to the hidden layers simultaneously. Okay. All right. So yeah. That's all for today. You can try this question by yourself. I'm not going to give you the answer. You can schedule and then you practice.
他给拜山来叫我特別但係點解要去自信？但係別信真係拜山。那都得到拜山拜山嘅。有關係7個雷的話，就是會有7個那個小圓圈input layer。
中還只有6個吧
？6個，因為來過第4個。
這麼難調。
這是output，然後其他都是 measure 的。
那 hidden layer 怎樣算？
他講depends on you，你考試有時間你要花20個。
然後全部 input layer 都要連的。
就每一個都要去。就一個，比如說這個，還有hidden layer 有10多個，然後就比如說10多個，比如說hidden layer 有10多個，然後那 input layer 一個就要連那10多個，全部都要連到。就這樣。就是窮盡各種。就是給他看過。
是啊，我們都看。
10多一天的課。